Okay, so we've got another implicit function here, and they want us to find the value of dy dx at the point 1 pi. Okay, so when we differentiate this here, we need to appreciate that we've got a product here, so we'll deal with that to start with. So the product is x sine y, so u will be the x and v will be the sine y. So when you differentiate, you have u dash is 1, so du dx is 1, and v dash is cos y, yeah? Sine y becomes cos y, but then you've got to times it by dy dx, because it's a y term. So that's what your dv dx is there. So when you use the product rule, then it's v du dx, so sine y times 1 plus then u dv dx, cos y dy dx. So that's this term differentiated using the product rule. So when we differentiate the whole thing then with respect to x, okay, well, x squared becomes 2x, okay. X sine y becomes this here, so plus sine y plus x cos y dy dx. Y cubed becomes 3y squared, okay, but don't forget to put dy dx on the end, okay, because it's a y term, equals to then, now be careful here, this is pi cubed will become 0, okay, not 3 pi squared. So don't try and differentiate this, because this is a constant, isn't it? You know, pi is like 3.14159, etc. And you're just cubing it, so it's a number. Okay, so when you differentiate it, it becomes 0. So then they don't actually want an expression for dy dx, they just want the value of dy dx at the point 1 pi. So we substitute that in. So we say, look, at 1 pi, well, x is 1, so 2 times 1. Y is pi, x is 1 again, cos pi, dy dx, plus 3 times pi squared dy dx equals 0. Okay, so we need to know what sine pi and cos pi are. Okay, now of course, because we're dealing with radian angles here, and we always use radians in calculus when we differentiate or integrate, it's always radians. Now you might know what that is, okay, or you can use your calculator, okay. So you might know that that is 0, for instance, because pi is the same as 180 degrees. Well, let's just check on our calculator, okay. So remember, you change the mode, so you do shift set up there, okay, and then you press angle unit and change it to radians. So if you type in sine, and then of course down here then you've got your pi button, if you press shift for that button there, so you've got the pi in yellow there, and that comes out to be 0, okay. So you get 2 here, plus 0, plus then, well, cos pi, now cos 180, okay, so let's just check that, will be minus 1, okay. So you can always check that on your calculator. So you've got minus 1 times dy dx, plus 3 pi squared dy dx equals to 0, okay. So you've got the same situation here now, where you've got 2 terms of dy dx, okay. 2 terms of dy dx, however, you can't put them together, can't you? You can't sort of do minus 1 plus 3 pi squared is something. So what we can do is factorize it. So we can do dy dx is factorized. So you've got minus 1 here, plus 3 pi squared. And then you can take the rest then over the other side, so that becomes minus 2 when you take that over. So then to get dy dx equals, you've got minus 2 on top, divide them by minus 1 plus 3 pi squared. So that is the value of it there, okay? So you could leave it like that. You could be smart here and just change the signs on the top. So minus 2 could become positive 2, as long as you do the same to the bottom. So you change the sign on the top, change the signs to everything on the bottom. So you get that there. So dy dx is 2 over 1 minus 3 pi squared. So you could leave it like that, or you could put it to a certain number of decimal places. Depends what they ask for. In this case, they haven't asked for any decimal places, so you could just leave it like that if you wanted to. Okay, or you could work out the exact value. On my calculator, I've got a value to be minus 0.0699. I'll stop there, maybe 4 decimal places. Okay.